So today's lecture, we will be starting with the first chapter in Science 1, that is laws of motion. Now, when I say laws of motion, what you should know is basically, first of all, look at the chapter's name. There are two words here. One is the laws and one is motion, right? So in physics, whenever you study about motion, you should understand what is motion, okay? Now, imagine that you are sitting in a train, okay? And the train is at rest. The train is not moving. You're looking out of the window and you can see, yes, everything is at rest, okay? But then when the train starts and you look out of the window, so what do you observe? You see that all the things which are there outside start moving behind. Because all the things outside start moving behind, that is why you can say that you are moving ahead, is it not? You are moving ahead because you can see all the things are moving behind. So when you look at any object outside of the window and you see that it is going back, you can sense motion. If these objects are not moving, then you cannot sense motion. So basically, when we talk about motion, motion is relative in nature. That is, we always consider motion of an object in relation to, okay? Like, there is another person sitting beside you in the train and the train is moving. So if the train is moving, the person beside you is also moving. But do you feel he is moving? Obviously, no, you don't feel he is moving, right? Because in relation to you, he is not moving. That is, you cannot sense the motion. But when you look outside, suddenly, you see things are moving. And then you feel, yes, that is motion. That is, motion is relative in relation to. In another situation, let's take another situation where your train is at rest. And on the other track, there is another train which is also at rest, right? So you are at rest, your train is at rest, and on the other track, there is another train which is also at rest. Then imagine that the other train begins to move. You must have experienced this, is it not? When the other train begins to move, what you feel? You feel that your train is moving. Yes, there is a possibility that your train may move, but even though your train is not moving, you feel you are moving ahead. Why you feel you are moving ahead? You feel you are moving ahead because the other train is moving in the opposite direction. And it happens many times that the other train leaves the platform and goes away, but your train is there only. It doesn't move. But when the other train was moving, you felt that you were moving. You must have experienced this. This is what I meant to say, that motion is relative. Now, when an object moves from one place to another, that object is in motion. But remember, motion is a relative concept. Like always, we consider that when the position of an object changes with respect to its surrounding, then there is motion. When you look out of the window and if things are going back and your train moves ahead, that is motion. But when you are at rest, and the train on the other track moved in the opposite direction, you felt there was motion, but there was no actual motion. You felt there was motion. Why there was no motion? Because your position did not change. You were at the same point. So understand this. You can feel motion many times because motion is relative. But when we talk about true motion, we say there will be motion if the position of the object changes with respect to its surrounding. Okay, so let me underline this, very important. If the position of the object changes with respect to its surrounding, then only there will be motion. Okay, so when the position of an object changes with respect to its surrounding, then there is motion. So let me underline this point, a very important point. If the position of the object is changing with respect to its surrounding, then it is said to be in motion. Okay, so very critical point. If so, I'm just marking it instead of underlining so that it becomes clear. If the position of the object is changing with respect to its surrounding, then it is said to be in motion. So when I started the topic, I gave you two examples. One example was you are sitting in a train and you look out. When the objects are at rest outside, you realize, yes, the train is not moving because there is no motion. When the object starts moving behind, you sense, yes, there is motion, and yes, there is motion because the train is moving ahead. That is, the position of the train is changing. Then I also told you one situation where there is a train on the other track and that train moves behind. You feel you are moving. You feel you are moving. But is that motion? No, that is not motion. Why it is not motion? Though you sense that it is motion. So when the object is at A and I told you that it is displaced by 5 centimeter, where it will be. Actually, I am giving you half information. As Jamdar told me that, you know, or somebody else, students will think and they will tell yes, that it can be in various positions. Basically, it can be various means what? I am not giving you total information. No? What I should tell you? I should tell you this, that object is displaced by 5 centimeter where? To the north, right? Or the south, or the east, or the west, or whatever direction, whichever direction. So what are information I should give you? Along with the value of 5 centimeter, I should also tell you what is the direction. Only when I am telling you the magnitude, this is a magnitude 5 centimeter, right? When I tell you the magnitude along with the direction, then only I can tell where the object will be. Okay, so I should have told you object at point A is displaced by 5 centimeter to the west. Then where it would have been? It would have been here, 5 centimeter to the west. So this is a very different quantity. So that is why this displacement which is there. No, see, I have written here displacement where I have written. I have written here. See, displacement where I have written. In what I have written. If you can see here, displacement. Displacement I have written in what? Displacement is directly written in vector. So basically vectors are those quantity, getting the difference, vectors are those quantity which have magnitude as well as direction. That is why I wrote this, magnitude as well as direction. And scalars are those quantity which have only magnitude. So remember this, scalars are those quantity which have only magnitude. Okay, so we say in physics, like scalars are those physical quantities which can be expressed by their magnitudes alone, and vector quantities are those physical quantities which possess magnitude as well as direction. So what the statement will be? So I will write the statement on a new sheet, that is scalar quantities are those physical quantities which can be expressed by their magnitudes alone, by their magnitudes alone. Okay, by their magnitudes alone. So scalar quantities are those physical quantities which can be expressed by the magnitudes alone. And what are vector quantities? Vector quantities this definition is not in the book, that is I have to write. Okay, are those physical quantities which possess magnitude as well as direction. Okay, so vector quantities are those quantities, physical quantities which possess magnitude as well as direction. So you have to write a heading in your book, scalar quantities, and then you have to write this definition, then you have to write vector quantities, and then you have to write that definition. First you write this, right, and if possible try to by heart it also at the same time. Okay, now children, we will try to understand the difference between distance and displacement. Now as we are in the SSC board, we have to follow the textbook rules. So let's have a look at the textbook. Okay, so they have given some situations, like you can see there are 2 points here. Okay, there are 2 points, one is A, another is B. Okay, let me zoom it out. And if you look at 2 points A and B, then they have also drawn something. Okay, let me use a different color. Okay, blue, I'm using blue. So they have reached from A to B like this, and I'll use red color here, and A to B like this. So we'll erase this part, the circle part, and we will just make it proper once more. Here, here, and this will be red, this will be blue, right? So you can see from A to B there are different ways of measuring it. Okay, you can measure it directly, A to B. Okay, or you can measure it through the blue line which I have drawn, or you can measure it through the red line which I have drawn. So then when you look at such situations, you can try to understand, you should know the concept between distance and displacement. Now first of all, the most simplest thing you should know is what is distance. Okay, distance is a physical quantity and it is a scalar quantity. Remember, distance is a scalar quantity. Okay, distance has only magnitude, it does not have direction. But when we talk of displacement, displacement is a vector quantity. It has magnitude as well as direction. Remember, distance is a scalar quantity. It has only magnitude. Displacement is a vector quantity. It has magnitude as well as direction. Now, to make it simpler, I will try to use the board and try to explain to you. Okay. Consider an object is at A and it is moving to B. Okay. And I mark here as the distance as 10 centimeter. Between A to B, the distance is 10 centimeter. Then in this scenario, the object is traveling from A to B and it is covering a distance of 10 centimeters. So distance in this case is 10 centimeter. And here the displacement is also 10 centimeter. But you consider another scenario where an object is going from A to B. Object is traveling from A to B and it is covering a distance of 10 centimeter. Then again it is coming back from B to C. Okay. Now this from B to C is 5 centimeter. So as I told you, distance is a scalar quantity. We do not consider direction. Actually, now object is gone from A to B and it is come back again from B to C, right? But in distance, whenever I calculate distance, I don't consider direction. So what is distance? It is the total distance basically from the initial point to the final point. What is the distance covered? Total distance covered is how much? From here to here 10, and then again it is coming back, that is 5. So what is the total distance covered? 10 plus 5, that is 15 centimeter. Why we are adding it? Because we are not considering direction, because distance is a scalar quantity. But when we consider displacement, again let's take the same example. A to B it is 10 centimeter, but B to C it is 5 centimeter. When we consider displacement, displacement is a vector quantity. In vector quantity we consider direction also. Vector quantity we consider direction also. So you see this direction it is 10, but then this direction it is 5, right? So what we do is displacement between this point A and C is 10, because this is 10, and 5 is reverse, right? Back, you know, direction which is opposite to the initial direction. So it is minus 5, that is 5 centimeter. So basically what I can say is 5 centimeter. I can tell you that this distance is 5 centimeter. Is it not? Let me try it again. See, from here to here, A to B, it is 10. And then from here to back C, it is 5 centimeter. Right? So what is displacement then? As I told you, 10 minus 5, that is 5 centimeter. Means basically what is 5 then? This is 5, is it not? This A to C, I'll not put an arrow. Arrow will change the meaning. Okay, so A to C, this A to C is 5. Because if you see this 5 plus this 5 is how much? That is 10. So from this, how you can define displacement? Displacement is the distance between the initial and the final position, or I can say it is the shortest distance between the initial and the final position. Displacement is the shortest distance between the initial and the final position. Let me try to explain this again, because this is a little confusing for children when they study first time. See, an object is going from A to B. What is the distance? 10 centimeter. Again it is coming back to C. What is the distance? 5 centimeter, right? So how is displacement calculated? In displacement we consider the direction also, right? So it is 10 minus 5. Why minus 5? Because this is in reverse direction, reverse to the initial, right? So you got 5. So mathematically if you see here, if you look here, so from here to here it will be 5, is it not? Because then 5 plus 5 will give you 10, right? So then if this green line represents the displacement, then I can tell easily that displacement is the shortest distance between the initial and the final point. Displacement is the shortest distance between the initial and the final point. Now we can come back to our textbook. Okay, and so from here you can tell easily what is displacement. So if you want to measure displacement, displacement is the shortest distance between the initial and the final point. So in that case, which I will take, what I will take, okay, think of that, what I should take. Green, let me take a green. Okay, so this distance, let me change the color, let me make it green so that it is different. So this is the displacement, shortest distance between the initial and the final point. What is the initial point? A. What is the final point? B. So displacement is this, and distance can be anything. Distance you can you know, if you are following the red line, then that will be the distance. If you are following the blue line, that will be the distance. But displacement will always be along the green line, because what is displacement? It is the shortest distance between the initial and the final point. Okay, so let's see in the textbook they've given the definition. Okay, so they have given this very interesting definition. Distance is the length of the actual path. Okay, distance is the length of the actual path. Distance is the length of the actual path traveled by an object in motion while going from one point to another. And displacement is the minimum distance between the starting and the finishing point. And I told you it is the shortest distance between the initial and the final point. So the meaning is the same, right? So this is very important. This you should know at the end conclusion, that distance is the length of the actual path traveled by an object in motion while going from one point to another, whereas displacement is the minimum distance between the starting and the finishing point. So please understand this. I try to explain to you with this, right? That in this case, the red lines indicate the distance, that is 10 plus 5 is the distance, that is the length covered by the object, okay, when it is moving. And displacement is the shortest distance, minimum distance between the initial and the final position. That is, you can see 5 centimeter is the shortest distance. Okay, so coming back to the textbook. So distance is the length of the actual path traveled by an object in motion. So you can separate out these definitions when you write. Okay, so you can separate this out and you can write this. Distance is the length of the actual path traveled by object and in motion while going from one point to another. Next heading you can give is displacement. That is the minimum distance between the starting and the finishing point. So you may get a distinguish on this, okay, distance and displacement. So remember, an interesting point I remembered here when we talk of distance and displacement. You know, an object is suppose going from A to B and it is covering a distance of 10 centimeter, let it be, and then it comes back to A. That means again it is covering a distance of 10 centimeter. So total distance traveled is how much? 10 plus 10, that is 20 centimeter. But tell me then, what will be the displacement? What will be the displacement? Displacement will be 10 minus 10, that is 0 centimeter. Obviously it will be 0 only. Why? Because its initial point is at A and final point is also at A only. Is it not? So initial is at A and final is at A. Means what is the displacement? Displacement is not there only. It was at A in the beginning and then again it is at A in the end also. Starting also it is at A, in the beginning also it is at A, and in the end also it is at A. Is it not? So is there any displacement? No. But then is there distance covered? Yes. What is the distance covered? This direction it is 10 and then back direction it is behind, again it is 10. So 10 plus 10 is 20. But what is the displacement? Displacement is 0. So when you study the distinguish, no, you can study, you can write like that. First point, distance is the length of the actual path traveled by an object in motion while going from one point to another. And displacement is the minimum distance between the starting and the finishing point. Okay. Second point, you can write distance is a scalar quantity and displacement is a vector quantity. Distance can never be 0. Distance cannot be 0. Okay. But displacement can be 0. Displacement can be 0. Is it not? Object starts from one point and comes back. It is 0. But distance cannot be 0. Okay. So these 3 points, basic points, now only we can pick up, and when we think more on it, we can get some major points.